Hello, my name is Susan Latanzio and I am a Research Associate within the Transdisciplinary Engineering Design Group, TREND, which is based at the University of Bath. The paper I am presenting is entitled Towards a Practical Approach for TE Education, a pilot study at the University of Bath. The manufacturing environment is changing. Smart factories and Industry 4.0 will result in complex systems where job tasks will be augmented by both humans and automation. Transdisciplinary TD approaches advocate purposive research which aims to address complex real-world challenges. As such, there is an expectation that engineering will be a designated field for TD. To deliver TD, there has been a call for the expansion of TD education, and within the literature we see papers presenting potential approaches such as new courses and project-based learning activities. The challenge with these approaches is that they are often difficult to implement, requiring considerable effort to plan and execute. This acts as a barrier to mainstreaming of TD education. In response to a requirement of educational leaders at the University of Bath, we aim to create a practical approach for TE education, a session which could be delivered by one member of the engineering faculty within a 2-hour period. Within this paper, we present the design and pilot of this session. Background to the origins of TD and TD education. The origins of TD can be traced back to an educational conference held in Paris in the 1970s. Within this conference, Jansch presented a paper which described a hierarchical education innovation system. This conceptualized TD as a purposive system aimed at achieving societal meaning and value. The system is divided into 4 levels. The highest level is the purposive level, societal meaning and value. Below this are the normative, social systems, pragmatic, applied sciences, and empirical, natural sciences levels. To achieve TD, all 4 levels of the system must be engaged, with coordination coming from the purposive level down. To deliver TD education, Jansch calls for the restructuring of the universities, which reorganise the institution into 3 types of units: system design labs, function-orientated departments, and discipline-orientated departments. As the students progress through their education, undergraduate, master's, PhD, they advance up through the units. The education system proposed by Jansch requires a significant shift from the traditional UK university setup. Students would increasingly move towards self-education, causing the university professor characteristics of the universities today to virtually disappear. Today, there is a lack of evidence to support that any university has implemented this approach. Rather, the tendency has been less revolutionary, with TD education incorporated into existing university structures, either through new courses, addition of new modules to existing course content, or by standalone project-based learning challenges. For universities, deciding on which strategy to take and designing new course content is only one of the challenges faced. By its nature, the content of any TD education programs will be broad. To deliver this content will necessitate the engagement from staff across multiple faculties and increased involvement from practitioners. Our research aims to overcome these challenges by creating the structure for a practical approach for TE education. The TE session design. The TE session was constructed to be delivered in 4 sections: develop motivation, remember, understand, apply, analyse and evaluate. The structure of the session was informed by 2 theories: the elaboration likelihood model and Bloom's taxonomy. Linked to the elaboration likelihood model Section 1 aims to motivate the students to engage with the information by detailing how the section is relevant to them. That is, how it links to the course learning outcomes or how the learning will be measured within assessments. Bloom's taxonomy is commonly used as a means through which to provide a shared language when designing educational courses. Aligning to Bloom's taxonomy, sections 2 to 4 progress the students through increasingly higher levels of learning. Section 2 is focused on remembering and understanding. Within this section, a presentation is given which provides the students with core information: the origins of TD, the current state of TD within engineering, and a structured approach for conducting TE research. Section 3 provides the students with the opportunity for application via project-based learning. Although there are many advantages to a project-based learning approach, in practice, it often takes considerable effort to plan and implement. Our research aimed to create a practical approach for teaching TE. Therefore, the project-based learning approach was truncated, with students asked to design the approach to be used within a project, but not to conduct the project. Within Section 4, the students were guided through a group discussion in which they were encouraged to analyse, evaluate TE. The specific areas they were asked to reflect on included the level of disciplinarity of the research projects they had assigned within Section 3, when a TE approach would be useful and not useful, and the enablers and barriers to a TE approach. Piloting of the session. The Advanced Automotive Propulsion Systems Centre for Doctoral Training aims to educate the next generation leaders in the automotive sector. The session was developed in response to a requirement of the centre directors and was piloted with their student cohort in November 2019. 8 of the 9 students took part in the session, which lasted 2 hours. Sections 1 to 3 were undertaken within the first hour, with the group discussion taking place in the section. Evaluation of the session was conducted by way of feedback, with the students invited to anonymously complete the standard University of Bath feedback form. The results showed broad satisfaction with the session. 6 of the 8 indicated they were satisfied with the quality of the session. 2 students were neutral. All students considered that the course material was presented in a clear and understandable way. All students considered that the course was accessible to their level of understanding. Receiving a less positive response was how the session fitted into the overall programme and around the clarity of the learning outcomes. This is perhaps a consequence of the session being incorporated within a pre-existing course without the opportunity of amending the description of the course programme. Conclusions and future work. The literature shows there are a lack of practical approaches for TE education. The research presented within this paper addresses that gap, creating and piloting an approach with students at the University of Bath. The results of the student feedback demonstrate that all of the students found the course material to be clear and accessible, even without prior reading. 7 of the 8 students considered the course was effective in helping them learn. Future iterations emphasise how the TE fits in the overall programme of study and to expand the time allocated to explaining the differences between disciplinary levels. Future work. The development of the TE session presented within this paper was the response to a need expressed by educational leaders. In meeting this requirement, theoretical discussions around the benefits and drawbacks of a TE education were not considered. Going forward and in testing the generalisability of the approach, questions of this nature must be addressed. There are plans to deliver the session to activity of our Engineering Business Management Business Innovation students, and informing agreements are in place to run the session in universities in Colombia, Korea and Poland.